Go.
Howdy, y'all. Today we're going to be graphing square and cube roots, and definitely not what the other thing was.
All right, let's go. All right, square and cube roots. I'm going to show you two ways to do it. I'm going to show you with some transformations. I'll show you how to use it. But I think that what I'll do is just show you in general, a general equation, and we'll go from there, and it'll make sense to you a little bit more. All right. We talked about inverses of parabolas and how if we turn it on its side and we take the bottom off, that is the square root graph, so you kind of know what it looks like. Let me give you the general equation here. This looks way worse than what it is. This is square root. Okay. Notice the A out front. That still does the same thing. We talked about function transformations. What does the A out front do? Shrinks or stretches it, right, vertically. It also flips it up or down, right? Reflections. And just like when we were talking about vertex form of a parabola, remember we have the H and the K in there? This is the same kind of thing, all right? So I think that'll be easiest just to show you that way.
Is the K outside of the curve?
Yes, the K is outside. The H is inside, and the K is outside. And together, they're still my vertex of that parabola, but it's on its side now, okay? So you can still think about it like a vertex, or I always call it a starting point.
Is it still negative?
Yep, this is still opposite. And same. Yeah, because if you think about, all right, so we've got this parabola, right? And this is the vertex. When we turn it on its side, this is still this point just on its side. So what a square root graph looks like is it starts at the vertex and then it goes off in a direction. It'll either look like this, or depending on if that A is negative, it could look like this. Okay, it's just that side wing of the parabola on its side is what it is. So what in general we do, the easiest way I think to graph these is really to translate this vertex to wherever it should be, right? So,
That one's positive.
Yes, that one's positive, and then the other one would be negative because it opens down. All right, so let me show you what I'm talking about. I think it'd be just easier just to show you an example here. Y'all got this? Mm-hmm. This really is not a hard concept, I promise. Let's say I had 2 times the square root of x plus 1 minus 3. If I am graphing this, this tells me that that vertex or that starting point would be where? -1, -3. -1, -3. And then what I always do is I find another easy point. Remember when we did easy points? Okay. Well, you want to plug in, and you want to make sure you go to the right of where you started. Because think about that parabola, whether it's up or it's down, it's going to go off this way, right? So I need to stay to that side. If I go to the left, if I plugged in -2, I'd have a negative under the radical. That's going to give me imaginary. That's not going to work, right? So 0. I'm going to put easy point. If I plug 0 into that equation, what do I get? 2 times the square root of 0 plus 1. Remember, just like Marshall said, that -3 is outside that radical, okay? Don't stick it under there. 2 times the square root of 1. And you don't have to write all of these steps out every single time. I mean, I hope you could look at this and know this was 2 times 1, right? So it's just 2 minus 3, which is -1, right? So my easy point here, and that's all you need to graph a square root graph for 2 points, a start point and a direction, to know which direction it's going off in. So 0, -1. Oh my goodness, that way. always use one beside that starting point. So whatever this starting point is right here, add one to it to get to your easy
Can we
point.
grasp the starting point?
Okay, where are you confused? I plugged into this equation. All right, so -1, -3 comes here, right? To find my easy point, I added 1 to where I started, and I just plugged in the equation.
Because this is the, so if we, this was just like a regular thing, it would be, okay. This
Okay.
is the inverse of a,
Correct. But it doesn't have the bottom part because then it's not a function, right? So we take that off. Also, you can't plug negative into a radical, right? Because you get imaginary. You can't do
isn't
that.
this the log functions?
No. But we will get there. Don't you worry.
We're gonna do sine for sine.
We won't get to that point now.
How do we know it curves back? Like,
Think about a parabola. Think about.
so just think like it's half a parabola.
It is. That's exactly what you think about. Shh, shh. Did y'all hear the question? How do you know the way it curves and that it looks like that? And if you need to put another point on there, you can. But think about the side of a parabola. You think about how that goes up. So this is the same thing, but on its side. Okay? Show you one more.
Wait, why is that the inverse?
Oh, wait, we didn't do domain and range. What's the domain? -1 with a bracket. Why am I putting a bracket? That's where it starts. Shh, guys, I'm having a hard time talking over you. How about the range? -3 to infinity.
Why is that the inverse? I thought you had a graphic parabola and then
Right now, we're just graphing it. In general, a square root graph is the inverse of a quadratic graph. All right, one more square root, and I'm gonna show you cube root, and I'll be done.
I feel like, were these some of the homework that we did last time? Was this like a way that we could have done things?
Possibly. And if you think about this in terms of parent graphs, the parent graph is just the square root of x. Let's do a negative. Sorry, I won't change it anymore. Maybe. No, I'm just kidding. I won't.
Do we need a good? Oh.
Oh.
Zero.
Zero.
-2, 0?
0,
2.
2. Think about your transformations. This one's going to flip down. That's exactly right. So now I need a direction point to know how to take this off in that direction. So 1. Why are you choosing 1? It is. I'm going to let x be 1 because it's 1 to the right of this one. So it'd be negative square root of 1 plus 2, which would be
So it'd be 1, 1.
correct.
Wait, why, so the last problem, it was -1, -3, but
Wait,
this
but-
one is 0, 2.
It's HK. H is missing, so it's 0.
So wouldn't it be -2, 0?
No, your negative is coming, your A is -1. And all that's doing, remember, all A does is flip up, down, skinny, wide. Stretches and shrinks. Mm-hmm.
But, okay, but isn't H 2?
K is 2. H is always under the radical.
So this is going to be.
Oh, okay, okay. Because you're-
Okay, so how I got 1. Take whatever X you start with and add 1 to it.
And it's not. That's for all of them? And it doesn't go down because it's an inverse. It's an inverse of the down.
The down just has to do with the A being negative in front. The inverse has to do with it being the half of a parabola on its side.
you know how you like add one.
Uh-huh.
What if it's like -3? Would you just go straight to 0?
-3, I do -2. You can choose any point to the right of where you start.
I thought you said that.
Well, if you started at -3, then what that means is that you would, your x here, it would have been square root of x plus 3. So if you plugged in -2, you'd still get a positive under the radical.
Oh, the right, you mean closer to the positive side, the right higher.
Yeah.
What is the S and B step for?
I just do, I've always taught, whenever I teach this in CP Algebra 2, I teach them starting point and direction point, and I just get in the habit. It's really, call it an easy point, call it a direction point. I tell them you need to know which direction to go. You need to know what to start with, where to put your pencil, and you need to know the direction to go. So that's why I call it start and direction.
So I know
It's
I'm going
really
down.
just the vertex and another easy point is what it is.
So I know I'm going down because it's a negative. But why would I choose the 1? Is because it's an easy point?
Because it's one more than what you started with.
Okay, so and then x would be 1, and then I'll plug it in for x, and then I get 1. And so is it 1, 1?
Yes. What's your domain?
Oh.
0 infinity.
That's right. Would you what, Lizzie? So what's the range? Right. It's going down on its own. Right.
So is that slowly like a going down? Slowly?
Thing about the side of that parabola that's inching out as it goes up, and now it's just on its side. All right, let me show you cube roots. If you can do square roots, you can do cube roots. I want you to think for just a minute. When you have a square root, there is an imaginary 2 that sits here. Why? Okay, so it's there. It's because you're asking yourself what times itself twice gives you what's under that radical, right? So what we can do, and it's the inverse of x squared, right? So we can change this to a cubed root, and then essentially what we're doing is we're saying what number times itself 3 times gives me what's under there. And what do you think it's the inverse of?
X cubed.
X cubed. Okay? It doesn't make sense, right? So, graphically, this is a parabola, and this is on its side, right? And we restrict it because we can't have a negative under that radical. What does the graph of x cubed look like?
Oh, it's the...
Well, but you don't have to restrict it, Callie's right. Why would you not have to restrict it?
It's just a line, it's just really. Oh, doesn't it pass?
It'll always be a function.
It still passes. It passes both. You're exactly right. And can I put a negative under here? Can I put a negative under this one? No. Not graphically, right? Because I'm going to be in imaginary land. But could I put a negative under here? Sure. Is there, let's put -1. Is there a number that multiplies 3 times to itself to give you -1? What? -1, right? Because a negative times a negative times another negative. So I can have negatives under an odd root like that. So that's why there's no restrictions there, okay? So I can have the whole thing. So the pink is what a cube root graph looks like. And it could be that way, or
Can we get a
I'm gonna show you.
Could we get a drawing that was like that and there's a big number under the story? Could we like tell us what the inverse is? Could we just do that number?
To find it on your calculator, what you can do, if you go to math, you see option number 4. That'll give you the cube root of the number. X cubed is, yeah.
Wait, so the one on the right, is that the
This is the negative, yes, yes. All right, so let me show you. The formula looks exactly like the other does. The only difference is, and this 3, make sure it sits kind of inside that little radical, otherwise it starts looking like 3 times the square root. This is why I do these together. They are so, so, so similar. HK, same thing. That's where I start.
Why is there not a 2 on the last?
It's just an implied, if you just have a radical without a number, it's an implied 2. Kind of like if you don't have an exponent, it's an implied 1. Same difference, yeah. Yeah. All right, so as you copy that, the only difference here, we're going to have the same start point, the same direction point, but we need 2 direction points this time. So we're going to go 1 to the right and 1 to the left. Exactly. That's the only difference here. It's a super, super easy concept. So square roots need 2 points to graph. Cube roots need 3 points to graph. Well, you have to start from that HK, and then you work from there.
Is it still same, or is it still,
Change and same. These are actually, I think, easier to graph because your domain's not restricted. So your domain on all of these will be exactly the same. It'll be negative infinity to infinity because you're not stopping and starting anywhere. Look at y'all on it. I can't even get the question out. -1, -2. That's the middle, okay? So keep in mind, if you need to mark that, sometimes I'll mark it with a little S to let me know that's the middle. So I need 1 point on either side of that. So I would do 0, and a lot of times I'll go ahead and do this so I don't forget. I need to make sure, otherwise you'll go back to one of those direction points and you'll start trying to subtract from there and you'll get yourself all mixed up. Okay? 3 points, the middle point, and then 1 on either side. That's all you gotta have. If I plug in 0, and as long as you stay one place over, you'll have a nice 1 in that radical. And the cube root of 1 is always 1, and the cube root of -1 is always -1. Okay?
So it's like, it's just above it, so 1.
It should be. So this would be 0 plus 1, and then subtract 2. Zero, -1, is that what y'all got? And then -2, so I'd have the cubed root -2 plus 1 minus 2. And here's where you probably have not encountered before, but the cube root of -1, we said, what times itself 3 times gives you -1, -1. So it's -3. That's exactly right. So -2, -3. And now you can kind of see, don't make this a line. It's not a line. Remember what it looks like? It's a cubic on its side. A little bit, like a stretched out S. What's the domain?
What do you do if it's like not just a 1 or a 0 in the formula? How would you find it?
Okay, in the radical, as long as you just add 1 to the start point and subtract 1 from the start point, it will always be 1 in that radical.
Wouldn't range be
So
the
then-
-3 to -1, right?
It's still negative infinity to infinity. These are creeping up
Oh.
and down.
Oh, duh.
Are you with me now?
Very slightly.
I'm just saying slow.
No, you're not. Okay, so believe it or not, that was 2 sections. That's why I told you. This was really, really surprising to see this in 2 sections because I've always taught it together. So, yeah, I mean, look at that. Like,
Wait, what?